Hi guys, welcome to the Science Chef educational series on chemistry. Today you will learn how to balance redox equations in acidic, neutral and alkaline media. So go nowhere as we will be right back after this break. Thanks for being there. Balancing oxidation-reduction equations is a bit more different and complicated than balancing non-redox chemical equations. This is because while the latter requires only balancing of atoms count, the former requires balancing charges in addition to atoms count. So, we will kick off by balancing simple ionic equation. A simple ionic equation is one that contains simple or monatomic ions only. Before we continue, let's consider the steps for balancing redox equations in a neutral medium while balancing the redox equation between aluminum foil and a solution of copper 2 salt. Step 1. In balancing a redox equation, the first step is to divide the equation into two half equations, the oxidation half equation and the reduction half equation, by determining the oxidizing and reducing agents in the equation. You may need to watch a tutorial on how to identify oxidizing and reducing agents in a redox reaction to have a better understanding. Aluminum is a reducing agent because it undergoes oxidation as shown in the change of its oxidation state from 0 to +3. While copper 2 ion is the oxidizing agent because it is reduced from +2 to 0. Step 2. Balance the atoms of elements in each half equation by using coefficients. This rule does not apply here as the atoms of aluminum and copper are the same on both sides of the half equations. So let's proceed to the next step. Step 3. Balance the charges by using electrons as follows. To the oxidation half equation, add the electrons to the right hand side. To the reduction half equation, add the electrons to the left hand side. Bear in mind that every mole of electron added is equivalent to -1. In our two half equations, the charge on the left hand side of the oxidation half equation is 0, while that on the right hand side is +3. So adding 3 electrons to the right hand side is equivalent to adding 3 negative charges, which neutralize the 3 positive charges to 0. Note that adding electrons to the left-hand side of an oxidation half equation only increases the negative charges on that side of the equation without necessarily neutralizing the overall positive charge. In the reduction half equation, the charge on the left-hand side is +2, while that on the right-hand side is 0. By adding 2 electrons to the left-hand side, 2 negative charges have been added to neutralize the 2 positive charges to 0. Then balance the number of electrons gained and lost using coefficients. Since redox reactions involve the transfer of electrons, it is always important to balance the number of electrons lost and gained. From our balanced half equations, 3 electrons are lost in the oxidation half reaction, while 2 electrons are gained. So we need to account for the deficit of that 1 electron by multiplying the oxidation half equation by 2 and the reduction half equation by 3. Step 4. Add the two balanced half equations and net off any species that appears on both sides of the equation to get the overall equation. When we add the two balanced half equations, 6 electrons appear on both sides of the equation, which are netted off to obtain the overall balanced equation. Since balancing a redox equation involves balancing the atoms count and the charges, let's confirm whether our equation is balanced or not. On atoms count, the number of aluminum atoms on the left hand side and right hand side is 2. The number of copper atoms on the left hand side and right hand side is 3. Note that when taking atoms count, we don't differentiate between atoms and ions because the charges on the ions are always ignored. For the charges, the total charge on the left hand side is +6, distributed as follows: 0 from the 2 moles of aluminum and +6 from the 3 moles of copper 2 ion. Similarly, the total charge on the right hand side is +6, also made up of +6 from the 2 moles of aluminum ion and 0 from the 3 moles of copper. So, we are good to go. Next is how to balance complex ionic equations. A complex ionic equation is one that contains polyatomic ions, especially those that contain oxygen and occur in acidic or alkaline medium. Let's consider the steps for balancing redox equations in an acidic medium. as we balance the equation between iron 2 ion and dichromate 6 ion in acidic medium. Except it is clearly stated, a reaction in an acidic medium is always identified with the presence of the hydrogen ion. We divide the equations into two half equations using changes in the oxidation states of iron and chromium as shown on the screen. Please refer to our tutorials on oxidizing and reducing agents and how to calculate oxidation numbers for a better understanding. The next step is to balance atoms of elements other than oxygen and hydrogen by using coefficients. This step is not applicable to the oxidation half equation as there is an equal number of iron on both sides of the equation. Remember, at this stage, you are expected to ignore the charges. However, in the reduction half equation, there are 2 atoms of chromium on the left hand side and 1 atom on the right hand side. So we add 2 to balance the chromium atoms on the right hand side. Step 3. Balance oxygen atoms by adding water molecules to the side lacking oxygen. This is not applicable to oxidation half equation 2 as it does not contain any oxygen atom. A look at our reduction half equation shows 7 atoms of oxygen on the left and none on the right. Thus, to balance this, we add 7 molecules of water to the right hand side, which takes us to step 4. Balance hydrogen atoms by adding hydrogen ions to the side lacking hydrogen. This also does not affect our oxidation half equation as it does not contain any hydrogen atom. So in our reduction half equation, after balancing oxygen atoms, we had 7 times 2, that is 14 atoms of hydrogen on the right hand side and none on the left hand side. So we add 14 hydrogen ions to the left hand side. The next step is to balance the charges just as in neutral medium. In the half equations, the total charges of the oxidation half equation are +2 on the left hand side and +3 on the right hand side, while those for the reduction half equations are +12 on the left hand side, obtained from the sum of 1 mole of dichromate 6 ion, that is 1 times -2, and 14 moles of hydrogen ion, that is 14 times +1 and +6 on the right hand side, obtained from the sum of 2 moles of chromium 3 ion, that is 2 times +3, and 7 moles of water molecules, that is 7 times 0. So we add 1 mole of electron to the right hand side of the oxidation half equation to neutralize the excess positive charge to +2, and 6 moles of electrons to the left hand side of the reduction half equation to reduce the excess positive charge to +6. We then balance the number of moles of electrons transferred or gained and lost by multiplying the oxidation half equation by 6 and the reduction half equation by 1. The last step is the same as balancing in neutral medium, which involves adding the 2 balanced half equations and netting off any spreadsheet that appears on both sides to get the overall equation. So on adding the 2 balanced half equations, 6 electrons appear on both sides of the equation and are netted off to obtain the overall balanced equation. Now let's confirm that our equation is balanced. For atoms count, the number of iron atoms on the left hand side and right hand side is 6. The number of chromium atoms on the left hand side and right hand side is 2. The number of oxygen atoms on the left hand side and right hand side is 7, while hydrogen is 14 on both sides. For the charges, the total charge on the left hand side is +24, distributed as follows: +12 from the 6 moles of iron 2, -2 from the 1 mole of dichromate 6 ion, and +14 from the 14 moles of hydrogen ion. Similarly, the total charge on the right hand side is +24, also made up of +18 from the 6 moles of iron 3 ion, +6 from the 2 moles of chromium 3 ion, and 0 from the 7 moles of water. So we are cool and dry, correct? Now let's look at the next step for balancing redox equations in an alkaline medium, as we balance the same equation between iron 2 ion and dichromate 6 ion in alkaline medium. Just like the acidic medium, if it's not clearly stated, the reaction in an alkaline medium is always identified by the presence of a hydroxide ion. To balance an equation in alkaline medium, you must first balance it in acidic medium using the steps discussed earlier. Then, for every hydrogen ion, add an equivalent number of hydroxide ion to both sides of the overall balance equation in acidic medium. From our balance equation in acidic medium, there are 14 moles of hydrogen ion on the left hand side, so we add 14 moles of hydroxide ions to both sides of the equation. Then combine the hydrogen and hydroxide ions on the same side of the equation to form water molecules. So adding the 14 moles of hydrogen and hydroxide ions on the left hand side of the equation gives 14 molecules of water. Finally, net off the water molecules that appear on both sides of the equation to get the final balanced equation. From my equation on the screen, there are 14 and 7 moles of water on the left and right hand sides respectively. So netting it off will reduce the 14 moles on the left hand side to 7 moles of water, hence the final and balanced equation. As usual, let's check whether our equation is balanced. The atoms count will remain the same as in acidic medium. It is only the charges that will change. Therefore, for the charges, the total charge on the left hand side is plus 10, distributed as follows: plus 12 from the 6 moles of iron 2 iron, minus 2 from the 1 mole of dichromate 6 iron, and 0 from the 7 moles of water. The total charge on the right hand side is equally plus 10, also made up of plus 18 from the 6 moles of iron 3 iron, plus 6 from the 2 moles of chromium 3 iron, and 14 from the 14 moles of hydroxide ion. So everything is balanced. It's now your turn to balance the following redox equations. So if you enjoyed this lesson, like, share this video, leave your comments and follow us on our social media platforms. Thanks for watching and always stay safe.